This building houses the largest, the most precise, the most energetic laser in the world. It reaches temperatures of more than 100 million degrees Celsius and pressures more than 100 billion times the pressure of Earth's atmosphere, creating conditions that only exist inside the cores of stars and giant planets. These conditions allow scientists to study fusion ignition, thermonuclear burn, high-energy density science, and the many other phenomena that drive modern nuclear weapons. Welcome to the National Ignition Facility. To understand how we got here, we have to start in 1960. Theodore Maiman builds the first light amplification by stimulated emission of radiation, or the laser. And the scientific world immediately begins to explore what this new tool can accomplish. A group of pioneering scientists at Lawrence Livermore National Laboratory hypothesized that lasers could be used to induce fusion ignition in a laboratory setting, using inertial confinement fusion, or ICF.
A number of people at the laboratory looked at the question of whether lasers could be used to ignite fusion. And so I had already run a lot of calculations, and I knew had calculated how big the laser would have to be.
It's been a goal of humanity since the 50s, since people started thinking about, we can do nuclear weapons, which is a downscaling from the sun, which does fusion. The question was posed early, is there a way of getting fusion to work at laboratory scale for various uses?
That question has taken decades to answer, and the answer wasn't always NIF. Beginning in 1962, the laboratory constructed a series of increasingly powerful laser systems, each 5 to 10 times more powerful than the last. As the growing program advanced the science of lasers, it also became clear that the applications of high-powered lasers reached much further than just ignition.
Understanding those processes has been what we've been working on since the 70s. So, it was over 40 years of work, gradually increasing the size and scale and complexity and capabilities of all of the components of this, the targets, the diagnostics, the laser, the modeling. So we had 40 years of experience leading up to NIF, and we used that to set specifications for what NIF had to do. And it had to be a huge leap in precision as well as energy. I mean, it's the combination of precision and energy that makes NIF such a unique facility.
By the time I became director in 1988. And the Cold War, which had been our major priority, not making bigger and bigger lasers, was coming to an end. And so I was beginning to think about the question of what's the 21st century Livermore Laboratory going to look at? And I came upon two main points. One of them was the big laser that would do ignition in the laboratory. And the second one was the supercomputer program, and those have been the two elements of the developing laboratory ever since.
In the 1990s, the U.S. stopped underground nuclear tests and in its place created a science-based stockpile stewardship program to maintain the safety, security, and effectiveness of the U.S. nuclear stockpile. This emphasized the need for a facility that could create the conditions that are relevant to understanding the operation of modern nuclear weapons without the need for full-scale testing.
Ultimately, confidence in the stockpile comes down to confidence in the people making judgments about it. So I saw NIF in both roles, both in terms of ability to make measurements of things that were important to the stockpile, but equally and perhaps in some ways more important, its ability to help train people to make decisions about complicated subjects, particularly when you have inadequate knowledge. And that's what NIF is, that's what ignition is. NIF was an absolutely essential part, is still an essential part, will always be an essential part of stockpile stewardship for me.
Our conversations were, look, we can't guarantee that stewardship and things like NIF and computing can replace nuclear testing, but we are going to learn so much more about these weapons than or at least the details of the science of these weapons than we've ever had. And so you need to give us a chance, because this is our opportunity to really continue a robust nuclear weapons program without doing the testing.
It no longer became something, are you willing to take this risk, but we have to have this, can you do it? Which is the way the laboratory was in the beginning. We were all in our 20s when I came here. We believed that we doubted there was any impossible.
This audacity has been the backbone of Lawrence Livermore since its inception, and the quantum leap from NOVA to NIF wasn't just about the science. A coalition of supporters had to make the leap as well. Policymakers, community leaders, other national laboratories, academic researchers, industry partners, and many more. These players helped key decision makers understand why NIF was important and what role it would play on a global stage.
This was too big a project that could not be done by the laboratory. The Congress, the DOE needed to want it.
Vic Reese, then the Assistant Secretary for DOE's defense programs, played a critical leadership role in defining the emerging stockpile stewardship program and the need for NIF, both then and now.
When you get a challenge and you can pull together a team of people who can work on that, these moments, in this case, several of these moments, these sort of happen and you just feel, an enormous sense of, it's really, pride is part of it, but of accomplishment when you can see people working together that way. And this was something that took a while to get started, but it really sustained itself for long periods of time.
Ellen Tauscher, California's 10th District Congressional Representative, was also crucial in bringing NIF to life from a political perspective.
She was a very astute lady. She spent time talking to us, learning about NIF before she ever decided, okay, I'm going to support this. So in some sense, she was putting her own credibility on the line. Her credibility was part of what was so important in developing a congressional consensus around supporting NIF going forward.
After the decades-long road leading to NIF, it was finally announced that this flagship experimental facility for stewardship would be built, and it would be built at Livermore.
And now I'd like to move to the reason I have come on this day, and that is to discuss something that was to have happened with my pen this afternoon. And that was and is the signing of the key decision number 1 regarding the beginning of the process of the building of the National Ignition Facility.
NIF was the natural and next progression in that whole series of lasers. And no one else had that background, that technology, or any of the other elements. And so if it was going to be done at all, it would be done at Livermore.
There's a few times in my life when I've been euphoric. When I got married, I had the kids, and NIF. I still remember after the groundbreaking was done, walking through 381 thinking, we did it. And so no, it was hard to describe. And it's still one of the most pleasant memories I have in my life.
While the first phase of the grand challenge of NIF came to a close, another began. Deciding to build NIF was one thing, but actually constructing it was a whole different story.
And even though we built a large number of laser facilities, NIF was an increase of perhaps almost a factor of 100 in capability, which meant that the construction and the operation would essentially be the first facility of this kind ever really done.
So my first impression of the big laser program was the work they were doing seemed impossible. Moving from this really small scale, hands-on work to these giant laser facilities. When I came on board as a postdoc, we were in the early planning stages for the facility, and the scale up from what we were working on at the time, the Nova laser facility, was just unbelievable.
To maintain the precision required of a first-of-its-kind laser like this, the facility around it needed to meet requirements that had never been set before.
That was the installation of the infrastructure, the steel, the beam tubes, which was a whole new world where we had to deal with, enormous structures that had to be installed clean, that had to be installed very precisely, and it was a huge challenge. We had at the same time we were still designing the laser, and so sometimes we had to make last-minute decisions just while the concrete was still wet, that we had to move some structures around because we found out there was a mistake in how the beams were mapped onto the target bay. So that was a very exciting time. So we were working 24 hours, we were working around the clock because we had a very tight schedule, and meeting that schedule, had huge impacts on costs, contractors, contracts, and so there was a lot of tension in there. We brought a lot of people in. We had people working in the weekends, at night, being there, working with the contractors to resolve issues all the time. So it was a continuous battlefield, and the fever was growing.
Construction of the football stadium-sized facility was a marvel of engineering in itself. But NIF is also a tour de force of scientific and technological development.
NIF was not a small step forward. It was not an incremental step. It was approximately a factor of 100 more than NOVA. And very few projects, very few institutions will take that kind of step. But when you do, there's a lot of things you can step into along the way. So when I got there, we were coming to terms with, really what was NIF, what was it being asked to do, where was it being stressed from a science point of view, technology point of view, an engineering point of view, and a management point of view. And in every place we looked, there were important problems, challenges that we had to face.
It's that creative discipline, you constantly have to be severe in saying, I'm not going to give up on this point. I'm going to achieve that goal, whatever it is, while at the same time you're creatively thinking about how can you meet that goal? What do I have to do? What do I have to change about the procedures that we have done in the past so that we can meet that goal? And it's a continuing process. You do that again and again and again and again.
In the end, the construction of NIF was a stunningly ambitious and complex undertaking, involving an unprecedented collaboration of a diverse workforce to solve the kinds of problems that arise when you push the boundaries of science and technology.
My typical challenge to new people when they come and tour the facility is I dare them to not be impressed. Because for me, it's the perfect expression of what Livermore is really great at. First of a kind, one of a kind engineering at scale. And NIF really is that in spades.
Talking about each one of the what we call the miracles of NIF, each one is a story in itself. Each one of which could easily have broken most institution, and yet we did a half dozen of them. We, the lab, did a half dozen of them. Ultimately, it is just because of the people.
When you think about what made NIF possible, it's always people, right? And we were lucky enough to have just the preeminent technology, management, procurement, legal, the big picture team to pull this together. And those people, deserve all the credit for everything that's at the NIF now.
In the years since official operations began, NIF experiments have made important contributions to stockpile stewardship, like resolving the decades-long investigation into the energy balance issue, supporting life extension programs for the U.S. nuclear deterrent, studying the behavior of plutonium at previously unexplored pressures, and making important progress toward fusion ignition.
To achieve fusion ignition in the laboratory would be a first in the world accomplishment and an incredibly important contribution to the stockpile stewardship program. And people can really see the kind of direct impact that that work is having. The science is really informing how we think about our nuclear deterrent and helping us to make smart choices and really helping us to make that system more sustainable into the future.
As foreseen by laboratory leaders decades ago, two of Livermore's greatest technical pillars have indeed become the National Ignition Facility and our high-performance computing capabilities.
The computing is amazing, but our computers are built on our knowledge. So to the extent that we have complete and perfect understanding, they really provide amazing results for us. But facilities like NIF allow us to plumb areas of physics where we really don't understand everything and where we have the opportunity to stretch our people and our tools and our capabilities in really exciting directions and engage with the outside world, really demonstrate the capabilities of this laboratory and its people.
NIF is unique in the pressures that it can reach in the world today, and so it allows us to study material properties in regimes that are important for nuclear weapons, but also for planetary scientists and astrophysicists and many other scientists, and study fundamental properties of material at these very high pressures that we didn't have a tool to do that before.
The other way that NIF is also unique is in the grand challenge of operating a facility at the level of accuracy and fidelity and scale that the NIF on a daily basis operates. So the ability to challenge our scientific staff and our technical staff and our engineering staff to reach the levels of tolerances that we require to enable any of that physics is another aspect that makes NIF very unique. Those both have to come together. And that's part of NIF as really a flagship facility in the U.S.
We were so excited about this progress. So every shot, whenever shot goes off, we wanted to see the neutron yields. And whenever the neutron yield goes up, I literally screamed so high. And then my colleagues said that they could hear me from Oakland.
But NIF isn't just the moment a shot goes off. To successfully support its increasing shot rate and the expanding diversity of stockpile stewardship experiments, NIF relies on the coordinated effort of one of the world's most dedicated teams, ranging from scientists and engineers to computer programmers, health and safety experts, and administrators.
I mean, I'm doing the experiment, but the experiment doesn't happen by myself. I need all kinds of support from all different areas. So if I need some kind of diagnostics, I have the best engineering team who can make it happen.
And it's, the number of people who use it, the number of people who talk about it, the number of people who think about it as a part of their lives is growing all the time. And sort of that's the big story. I mean, it's, the big story is today, not yesterday.
And it's not any one group, again, that can do it. It's the targets, the diagnostics, it's the people who design the experiments, like Laura.
What physicist wants to be told you can't do that? Basically no one. I think most physicists see that as, great, that's an opportunity for me to show that, no, I can do that, I can solve that problem. And that's really been many hurdles along the way to reach where we are now. And there will continue to be more hurdles, and I expect that we'll continue to try to understand what those hurdles are and how we can get over them.
For me, or my dream is that we actually will be able to demonstrate that and, show that what Knuckles dreamed about in the 60s really is doable, and that NIF is the laser that is going to make that happen.
I like to say all the time, I'm an optimist. I think you have to be an optimist to work in fusion. So I think we'll get there in the next decade. But even if we don't, we'll have done our job if we can answer what's required and put the nation in a place where it knows what the next facility it needs to build is to reach that goal.
The original vision for the lab's boundary-breaking lasers has evolved over the decades to see the dream of science-based stockpile stewardship become a reality. In 2019, NIF remains unmatched in the world as the sole point of access to these unique physics regimes, and has inspired other countries to try to emulate its success. The courage, foresight, innovation, and collaborative spirit of the people who brought NIF to life are tenets that have been with the laboratory since its inception, and will be what powers NIF as it operates into the future.